Cookies. It's what makes the world go round. Everyone loves a good chocolate chip cookie. Me, you, even Lily's Long. Speaking of Lily.
Hi, I'm Lily. Chances are you've had 1 or 2 or even 3 chocolate chip cookies in your life. Who hasn't? Not me. What if I told you that throughout the creation of such a delicious, mouth-watering treat, college-level chemical engineering concepts are applied to ensure your cookies are baked to perfection?
Oh yeah, it's called heat transfer, and it's everywhere when you're baking something. To be specific, there are 3 types of heat transfer: conduction, convection, and radiation. And they are all there during the baking process. The second you put the cookies in the oven, assuming you preheat it like any competent baker, heat, otherwise known as thermal energy, is being transferred to those cookies in 3 separate ways.
The first way is through radiation. Electromagnetic radiation is generated through the oscillation of dipoles in matter, which are a result of intermolecular collisions between the atoms. Although all matter with a temperature higher than absolute zero emit thermal radiation, the bottom of the convectional oven emits a large amount of heat through radiation. The heat transfer occurs through electromagnetic infrared waves, specifically through the energy transmitted from a surface through these waves.
Radiation can be represented through radiative flux, which is the rate of radiative emission per time in surface area, also known as power per surface area, to measure how effective a surface is at emitting energy. Emissivity is used in reference to the black body. The black body is a theoretical body that absorbs all wavelengths of thermal radiation that is on its surface, so they do not emit light and hence appear black. Emissivity can then be described as a ratio of how well a surface can emit radiation in comparison to a perfect black body at the same temperature and area, ranging from 0, where the surface would be the perfect reflector, to 1, where the surface would be the perfect absorber. Materials with a high emissivity are good at emitting both and absorbing radiant energy.
This can be seen in baking when it comes to dough pieces being heated in an oven, since objects such as dough pieces will absorb part of the infrared energy impacting on them and reflect part. The energy absorbed penetrates the dough pieces and rapidly heats the center of them, as well as the surface, by setting the molecules within the dough pieces into vibration. The temperature of the dough piece is a measure of the The temperature of the dough piece is a measure of the average kinetic energy of its molecules, which increases due to the radiation from the oven surfaces in the baking chamber. The effects of this method are especially apparent if you're some kind of heathen who heats cookies up in the microwave, where the center of the cookie is baked quicker than the outer surface.
So now that we learned about radiation and emissivity, let's think back to our oven. The heat source is at the bottom, and the cookies are obviously on top of some type of steel tray, like this. The tray is being heated at a much quicker rate than the cookies, which leads into our next type of heat transfer, good old conduction.
Conduction is the transfer of thermal energy between neighboring molecules within an object or between objects in contact with each other. This transfers energy from an area of higher temperature to an area of lower temperature and impacts the... It's electric. This at a lower temperature and acts to equalize the temperature difference.
Well, we actually can do that
We can continue. I can edit that out or something.
Thermal conductivity K is a property of a material that indicates its ability to conduct heat. If the material is a good conductor, it will transfer heat with a small decrease in original temperature. Therefore, a material with a high thermal conductivity value will produce greater heat loss in a small change in temperature. Carbon steel has a thermal conductivity of 54 watts per meters Kelvin. The thermal conductivity can be used to predict the power loss in watts through a piece of material through the calculation of heat transfer.
The conduction of thermal energy to the dough pieces during the baking process is most relevant to baking on a carbon steel baking tray. The cookie dough is placed directly onto the baking tray and placed into the oven. In the oven, heat is conducted rapidly into the base of the cookie dough via the baking tray, which has a large area in contact with the dough. The conduction of the heat to the base of the dough piece is optimized because of the large surface area and contributes significantly to the total heat transfer.
Thermal conductivity is also important in calculating the optimum insulation required for the oven. The oven should be well insulated with material with low thermal conductivity, therefore producing a lesser heat loss and a large change in temperature. This is so that when one comes in contact with the oven's outside, the temperature on the outside is significantly less than the temperature inside the oven.
The baking chamber must be effectively insulated to also minimize the heat loss from the oven to its surroundings. Heat is conducted from the walls of the baking chamber through the insulation to the outer covers. The amount of heat conducted depends on the material, quality, and density of the insulation. Materials such as mineral wool, normally used for oven insulation, have a low thermal conductivity. The mineral wool typically has a thermal conductivity of 0.06 to 0.1 watts per meter Kelvin at baking temperatures.
Now, there is one more type of heat transfer to talk about, and that's convection. Convection is heat transfer due to the movement of a large quantity of molecules in fluids, gases, and liquids specifically. In our case, convection is a heat transfer system that uses jets of hot air. Okay, that's just like, what?
It's just like, what?
Like, you see that? Like, in our case, convection, a heat transfer system that uses jets of hot air blown directly. I think that's supposed to be the oven. How about this? In our case, convection in an oven involves a heat transfer system that uses jets of hot air blown directly onto the surface of the dough pieces from above and below.
Quite honestly, I use the convection option whenever I want something to bake faster.
That works too. Since the hot air is being circulated above and below the dough, the entire dough piece cooks faster than it would just being heated at the bottom. Nice job, Lily. This hot air rapidly increases the temperature of the surface of the dough piece. The convection baking system is usually controlled by altering the temperature of the air, which is blown by the circulating fan in the baking chamber. This convection system only affects the top surface of the dough piece because the bottom of the dough piece is fully shielded by the pan. The heat transfer to the base of the dough piece is solely by conduction.
This way and then through.
Oh, through?
Yeah. Yeah!
Oh, that cannot be it. Cookies. Okay, wait, I don't know that. I just need to warm up round.